Thanks, Dion, and thanks for having me. Just to give you a bit of background of myself, there's a little bit there. Metallurgist, so I'm not a lab type person, so bear with me, but primarily been involved in gold, base metal and precious metal refining for the last 20 odd years. Joined Mineral Process Control in March last year, so fairly new to the business. Some of you, well, a lot of you may know the likes of John Cooper and Rob Mason, who started the business. They're really the drivers of the business, and I've joined to assist them with that. I just want to give a general overview of the Pulverise and Leach system, which I know some of you are familiar with, so bear with me. But just to talk about its application, for those of you who are not familiar with it, just how it works, what it does, where it fits within the assay scope of things. So we'll push on. Yep, just my details. If you want to take it down, if there's an information thing in the satchel you got out, but just in case you need to get in contact with me. All right, so to talk about PAL, we really need to talk about a brief history of MPC, because it's been a very iterative process in terms of its development by both John and Rob. And these dates here, which are straight from John Cooper's memory, so hopefully they're accurate. It really started with leach well product, which those in the gold industry are no doubt familiar with. Now, that was developed by a gent called Dave Menny, who's South African, who's since passed away, and it's a cyanide accelerant. So it's basically added to cyanide bottle rolls, blegs, to accelerate that process from traditional 24-hour bottle roll to determine recovery analysis for gold down to an hour. So the obvious effects are that you're able to get time efficiencies and labour efficiencies out of that process. And primarily in 1995, that's what the business was set up. And really, leach well is followed all the way through, because the PAL system does use leach well. So it's a constant through the whole thing. Then in 98, an assay tab was developed, which is basically a combination of cyanide and leach well in the correct ratios, and it allows the user to safely and easily add an aliquot of leach well and cyanide into a bottle roll or a PAL as it's used, to be able to easily handle that material. What we found that when the tablet was put inside a bottle roll, because of the size of it, it's 10 grams, it's about the size of a rocker, it didn't basically break down. There was still a residual amount of the tablet left over. So the tumbler was then developed, which is basically an end-on-end tumbling action for blegs, which then breaks down and it's a more efficient mixing reaction. From that, the idea was, well, how can we incorporate that tumbling action, but also get rid of some of the issues in terms of time taken for sample preparation. So generally sample preparation from a larger sample, as you guys would know better than me, you do your splits down to, say, 50 grams for a fire assay, or 30 grams, whatever you're using, and that's a fairly involved process: crushing, splitting, pulverising. So the idea came up with having one simple system where you could put a relatively coarse sample size of a gold ore into the one pot, leach and pulverise at the same time, hence the PAL system coming about. First unit was put in between 2000 and 2003 at Big Bell. Proved quite successful to the point we've put 80 units into service now. In the last 30 odd years, I think there's probably, of that, probably about 40 left, still operating. Latest one, I think one of the gents here is assisted with up in Superior Gold in Billabong, putting in place. So they're still very well utilised for what it actually gives the customer. Now, 2023 plus, we're probably looking at containerised systems to be able to better utilise it in remote locations. And make it a bit more user-friendly in terms of putting a short-term solution in place. So what is PAL, for those who don't know? It's a cyanide dissolution and fine grinding of the sample, which I'll show some images so you can get a better understanding. It's a progression of the bottle roll technique, bulk leach extractable gold bleg. The advantage is it has a large sample size. So you're talking a kilo going into the PAL generally. Some operators use smaller amounts, but generally we say it's a PAL. It's 1,000 grams. Because you're actually only taking the sample, crushing it down to say a 2 mil feed size, which is generally the feed size you're utilising it, putting straight into the system after you split out, the requirements for preparation are reduced, with the obvious advantages with that. So there's a time cost and plant applicability. Now, what I mean by that is it's a gold and silver cyanide dissolvable assay. So it's effectively a 24-hour bottle roll on your sample within an hour. What does that mean? From a metallurgist's point of view, that's probably the most important assay that I want to see, which is the recoverable gold, total recoverable gold. And as you'll know, depending on the ore body, that can change from within the ore body or from different satellite ore bodies. So it's an extremely valuable bit of information to have. So from the pulverised point of view, it's a planetary type milling action. It's deliberately designed that way to produce quite a very fine product. It's within a cast iron pot. This is just the physicality of it. It's a cast iron pot containing grinding media. 1 kilo sample, 2 millimetres. Although you can put up to 10 millimetre in there, although that does take longer and will slow the process down. But if you want to put that material in there, plus you can change the grinding media to accommodate as well. Typical grind size, and I've got some data there, which there's too much data for you to see, so it's graphical. So you'll be able to see is typically a P90 of about 75 micron, typically. However, you can change that and get much finer grind as well if you need that. And that's the beauty of the system because it does mimic your processing plant. So if you need a finer grind, if you're finding that if you get a finer grind with your PAL and you're getting better recoveries, that your plant isn't getting those same recoveries, then it does indicate to you that your plant's not performing the way it should and you maybe need to do something about that. The leach, it's got the measured reagent addition. It uses the assay tab, which is what I spoke about earlier. You add the water, the sample, and the assay tab, and it's that simple. Okay. The assay, gold determination via AA or ICP, generally speaking AA, because you're only looking for the gold assay. Detection limits, we typically say about 0.01 ppm. Okay, so that's quite good. And then solvent extraction if you require. So pretty straightforward from the back end point of view. What have I done? Oh, is it this thing? So everyone will have to crowd around.
Yeah, that's weird.
Generally say 6 weeks, but that was tested in the last 12 months. We've got to the point where we've got units on hand, so we can deliver within a couple of weeks. Okay, so that's what the unit looks like for those who are familiar with it. And I'll go into the specifics. So this is the basic guts of the unit. You can see those cast iron pots there. That's what takes the sample. Within those pots, you'll have the grinding media. There's a bar across that takes 13 pots. There's 52 pots in total. And basically, you'll add your sample in there, lock it in with your water and your assay tabs, and start the process. And I've got a bit of a video so you can get an understanding because it's hard to talk through, but it's easy to watch. And the baskets at the front are primarily for capturing the grinding media. I'll go into each slight change in that we're putting in place. So you can see the grinding media there. Now, thing with it, we used a product called Power Peps, which was used for tower mills, and that's why we were able to get such fine grinding with the planetary action. But you can also, generally you'd use a 27 mil ball charge, but you can use a 36 if you have a larger top size. So it's pretty much the same as your grinding media in your plant and how you determine that. Now this is a video which I hope will work, which shows you the action. You can see there, that's the action. So as the sample in there and that goes down and down, it actually each of the pot is moving in an opposite direction from the main part. So, 52 samples generally take an hour. But it does get a lot, but I wasn't willing to take the footage of it. So what are the advantages and where can you use it? Because obviously there's a lot of technologies out there for gold assay, fire assay, photon, etc. So where does it fit? Okay, so it's one of the key advantages. It's relatively low cost to start up. You're looking less than 100,000 for total. Labour costs, you only need one person for 2 machines. Sample throughput, depending on your runtime, 600 to 700 samples a day. Damp samples can be processed if you want a quick turnaround. Okay, you don't have to dry them. Pulverising, obviously. There's repeatability at a relatively coarse particle size. So it's got excellent repeatability. Gold smearing, if you come across that with large coarse gold, which you often see in a pulveriser. When you pulverise a large coarse sample, you'll get smearing of the actual pulp. That's eliminated. Excuse me. Training, I feel, is pretty straightforward. It doesn't take much to train someone to put it in place. And the sample costs are quite low. These are quite old numbers, but the estimates for $750 a sample, $250 to $350 a sample for your own lab. But I'm sure the lab operators will probably tell you better numbers than that. That last point there, second last point in terms of leach time, there is some functionality and variability. So you can vary the time, you can vary the media size, you can vary the speed as well. So that gives you some wriggle room to play with to try and, first of all, mimic your actual process plant. So that's effectively what you're trying to do. So you'll understand your gold recovery. Excuse me. But also, if you need to do any, from a process point of view and a process engineer point of view, you can easily do some plant process control type work on that as well. And there's no, due to the amount of cyanide that goes in there in leach well, preg-robbing issues are generally overcome. Some more advantages. I'll quickly go through them. Suppose I wouldn't say 100% recovery of cyanide leachable gold, but if you're getting up there, you can do a simple recovery testing just through doing fire assay on your tails. Okay, so if you're able to retain your pulp, and we're changing the design so you can actually easily retain the pulp after the leach, you can simply do a fire assay on the residual material and you can get total recovery. So by doing that, you're able to effectively understand your total gold in your ore body and also what your expected recovery is. And arguably, the only way that you can do that would be through fire assay plus a bottle roll of a separate sample, or a split sample, sorry. It's suitable for oxide or fresh material, and I'll go through the disadvantages and the considerations in the next slide. Obviously spoke about a large sample. That's excellent because of that. It's good repeatability. Spoken about the grind size. It presents well according to CRMs that we've been put through, and it's got doubled up there in terms of repeatability. You can use it, it's a 52 pot machine, you can use it for smaller sample runs, so there's a flexibility there, but you need to be careful because of the speed of the machine, it can quickly become unbalanced, so probably recommend against that. And this is the other thing, it is mechanically very robust. I have a picture which I wasn't allowed to share. We had a machine that we put in the back sea container, it went all the way to Ghana, and then they sent a picture of it where they pulled it out of the container on the back of a flatbed truck and it was lying on its side. So as I said, 40,000 kilometres you got it to us and then we destroyed it. They literally pulled it up, turned it on and it was running. They're very robust pieces of machinery. And that makes them ideal for remote mine site applications or laboratory applications. The considerations, like every technique, it's not 100% foolproof. It presents a gold and cyanide leachable form. So obviously if you've got a refractory ore body where you have to do some sort of pre-treatment of your ore prior to putting through CIL, CIP, then you won't get a total 100% or 90+% recovery. That in itself is good data though. So we had one customer in West Africa who passed a lot of their grade control samples through and were getting 60% recovery. The grade control turned out there was a refractory part of their ore body that they weren't aware of. Now, they were able to pick that up in the initial sample, grade control, and it didn't go through their plant. So there's a benefit in that regard as well. But obviously, the high refractory component, it may not be as suitable in certain aspects. There is a certain amount of recovery during cold weather, but that can be overcome, leach time, warm water, etc. But that's a consideration. The charge size is 1 kilo. We have had people ask for 5 kilo charge size. Not quite sure what they would do that for, but that is feasible in theory. Clay materials, you do need to drop your charge size just through material handling and slurry requirements, but that's not necessarily a problem. QA/QC testing, generally the way people do QA/QC, and the guys who've used it would know better than I, is through repeats or duplicates, but that allows you to understand your precision but not necessarily your accuracy. So obviously you can put CRMs through. We're working with a company to be able to produce a cost-effective CRM, and hopefully they'll be on the market soon. And you can really, there is a minimum charge size. The recommendation, you don't want to go below about 100 grams, okay, because then you'll start having issues. Okay, there's a lot of data there. It just shows you the grind size. These are some grind tests. So on the left-hand side, that's the passing 75 micron. So you can see there the bottom range is an outlier below 90, but pretty much most of the data is above, say, 95% passing. So it shows you the 1400, over 1400 grind tests, the percent passing. Too much data there, okay, for you to see, but this is the performance against a CRM. Probably the most important thing on the right-hand side there, it's within 1 standard deviation of the result. So there's good repeatability and accuracy. I can share this data with everyone, whoever needs it later. I can see all the statisticians looking at it, getting excited. Okay, so what's this represent? PAL versus a class 2, that's basically a bleg. So I put this in here just to show you that there is in the bottom hand you actually have the PAL assay, and of the same sample we've undertaken a bottle roll, effectively. And it's just to illustrate that apart from some higher assays there, we're getting good repeatability and correlation between the bleg assay and the PAL assay. So in other words, it's illustrating that effectively you're getting that same recovery result, but a lot quicker. Yes. Yeah. So what Rob just asked, whether it's been ground, so it's been pulverised before it's put in. Okay, again, a lot of data, but really this is just to show the repeatability. The top ones, these two graphs basically show sections of the same data. The top one's the total data, which is basically the first PAL assay and the second PAL assay. So the same as the previous test in regards to comparison, but we've split the sample, put one in one PAL and one in the other, and you can see there's reasonable repeatability. There's some outliers at quite high assays, 300 grams per tonne, which I'm not sure too many mine sites can have that anyway. And the bottom chart is really just an expansion of that 0 to 25 ppm off the top chart. So you can see there is a reasonable repeatability, which is increased down at those lower gold contents. There's a bit of data analysis on the side, which if I send that out, you can read later. So what's it used for? That's a big question. Now it sounds fantastic. We believe it can be used across the entire chain of mining chain. Primarily at the moment it's used in grade and process control. A lot of our users are using it for grade control. with the corollary that you also get process control at the same time. But we also feel that if you utilise the PAL earlier within your exploration and feasibility, you'll actually get data a lot quicker and you'll move that along. So if you're doing an exploration phase, you get exploration samples coming in, you put that through a PAL, you do a fire assay on the tail, you're getting total gold and recoverable gold early on in the process. Now, I know geologists love total gold and that's all they like. Okay, so it's a bit of a push to try and get them to understand the utility and efficacy of using this type of result earlier on in their exploration process. This is primarily, it's a global application. We have a big footprint within Australia, obviously. West Africa is a big market for us, as well as increasingly into the Americas. Now, why is that? Basically because of how robust and simple it is to use. It's almost a plug-and-play piece of equipment. You can put it in there with an AA and off you go. It is highly suited for remote mine sites, and because of the cost effectiveness of it, it'll get you going straight away. So we're finding more and more of our users are ordering it, putting in place where they need quick turnaround, good detection limits on their grade control / process control samples. Okay. Like I said, we've produced 80 odd units to date. We've got another 10 in line to send out to customers, and more it's being used as one part of the fit within the assaying suite of products that you can use. And that's it. Any questions?
Yeah, you mentioned.
Apart from Rob.
Sorry.
Sorry.
You mentioned that there's been a queries towards 5 kilo charges.
Mm-hmm.
That's not the same pots though, is it?
It'll be different pots, yeah.
Yeah. So it's the same machine for your pots.
Yeah.
Yep. So the question was about bigger pot sizes, 3 to 5 kilos. So you just change the
Yeah.
pots.
So there's a couple of ways that you could get a 5 kilo sample and then split it, and then have 5 different repeats of the same sample, which give you information. But obviously, if you're wanting that 3 to 5 kilo, we'd have to redesign and put a larger pot in there, which is doable, but no supply just yet.
So you mentioned that we discussed this before a little bit, is the capturing of the tails after the leaching process. So with that, is that going to be with new units, or is it going to be able to be retrofitted to old units?
So if you saw the design of the unit itself, it has a polypropylene tray at the front which captures the media, which I illustrated that in the image. At the moment, the way the design works is those you tip the once you've had the hour or 45 minutes of processing, excuse me, you'll take the lids off, you'll take a sample of the solution, and you'll just tip those pots out into the media and baskets, and the slurry will combine and go into a trough to then be pumped off to the mill or wherever it may be. The design changes has changed to that trough. It's a bigger, deeper trough, and it basically has 13 polypropylene cylinders where you can actually retain each sample individually.
Any other questions from the crowd?
Just from the quality control side of things, have you looked at doing a recovery process in standard? So similar to fire assay, where you have a known amount of silver in for silver analysis.
Mm.
Have you looked at doing something like that? Using a barren sample that you can dose it with?
So using like there was a product, assay pills, I think they were called, something similar to that. You can utilise that as well, yes. Yeah.
I don't have a question, but I just like to say that I know this technology from Turkey. Yeah, it was very amazing. If we use it as now making gold, the yes time, we had 60,000 samples. We buy it every 10 sample.
bit of it after crushing. And the comparisons were unbelievable. In fact, the assays there were up to 1,000 ppm, and we would follow up by watching the plots after we'd actually done that sample in that plot, in case of carryover. We had no carryover, 1,000 ppm sample. Anything that was over 10 ppm, we would follow up just in case it was pretty amazing. Technology's improved since then, but it's pretty mind-blowing back in enthusiasm.
Great reference, Nathan. You're going to get him on video. Something like that, mate. That's good. No, it's good to share people's experiences. Again, that's what this event is more about than anything else. This is people sharing knowledge and Nathan, sharing technology. So if there's no more questions, give your move around forward.
All right.